Hello everyone. In the previous class, we have learned the basics of surveying. We have learned the definition of surveying and objective of surveying. Along with that, we have also learned classification of survey based on object of survey and classification of survey based on instruments used. And we have learned so many classifications of surveying in detail. In this class, we are going to discuss about the principles of surveying. Let us start today's class. So let us see what are the different principles of surveying. So these principles apply in the entire surveying. So we have two basic principles of surveying. First one is always work from whole to part. The second principle is location of a point by a new point or with reference to any two known points. So we will discuss in detail about these two principles. This shows the framework of triangles which we perform during the survey. So this diagram shows we have divided the entire area into number of triangles. The surveyor should establish accurately large mainframe work consisting of widely spaced control points, say A, B, C, D, etc. Now this large framework is to be divided into a number of interconnected triangles. As I have already shown in the previous diagram, the entire framework is divided into number of interconnected triangles. So the large triangles BEC is further divided into smaller triangles, further subdivided into similar triangles. And interior details in these small triangles are surveyed with less accurate methods. Due to this, we can avoid accumulation of errors. If the survey starts from smaller triangle JKL, the error get accumulated during the extension of survey, due to which we are not starting with part to whole, but we are doing from whole to part, so that which avoids accumulation of errors. Hence, survey is acceptable from whole to part. And we have another principle to locate position of any point by a new point or a line. Line is nothing but joining of 2 points. Here we have with reference to two known points and with reference to a linear line or angle, or both linear and angular measurements. Let A and B be the two known ground points. Point C can be located by the following method. Here in the figure 2, A, B are known points. Now we are going to establish a new point C with respect to these two known points. So by direct linear measurement AC or BC and the perpendicular distance CD, we can establish a new point C. Or we have another type of establishing a new point C. Here by two linear measurements AC or BC, directly measuring from A and B. And the third type to establish point C is by angular measurement from B and a linear measurement from A. So which indicates the distance AC and angle beta. So in these three ways we can locate a new point with respect to already known points. So these are the two basic principles of surveying: working from whole to path, and location of a new point by two known points or one point and one angle. So this also can be done. Angular measurement is taken from point A and the linear measurement is taken from point B, which is exact reverse procedure to the previous method. And finally, we have two angular measurements, alpha and beta, by which we can establish new points C from A and B, which are known points. These are the methods by which we will establish new points. So the following points may be noted while performing surveying. The cost of survey increases with an increase in accuracy as follows. If less accuracy is sufficient, chain survey can be adopted, which means the accuracy required for the survey is not essential or not much more, then we can adopt chain survey. If we want more accuracy, we need to use steel tape. Still more accuracy is required, then instruments like compass or theodolite are to be used. So it depends on accuracy required. Initially, we discussed that the cost of survey increases with the increase in accuracy. There is always a possibility of making errors while taking the measurements and recording the observations. Hence, there should be suitable provision for checks. As a human being, we are always prone to making errors. So in the process of doing survey, there must be some checking points so that we can check the survey in between the survey. So there must be a provision for checking the survey details. All the measurements taken in the field must be recorded in a proper field book at the time of measurement itself. Some people may say that they will record later. First, we will take the measurement, due to which there is a possibility of uh, forgetting the readings, and there is a possibility of entries of wrong entries. So at the time of measurement itself, we have to enter the readings in the field book, which is very essential. And it should be a neat and clearly written, such that others can plot from the field data which is recorded in the field book or in a map. Some people, if they won't write clearly, it is very difficult for others to understand and interpret the data. So in such case, the data has to be taken again, or you have to go for the survey again. To avoid this, we must write the data clearly such that it should be useful for everyone and it should be understandable for everyone. The field book is original record of data and it should be kept in safe custody. As field book contains the field data, we cannot keep it anywhere, but it should be kept in a safe custody. After learning the procedure for some of the points to be followed, or points to be noted while performing survey, we will go to the purpose of chain surveying. We'll discuss what is chain surveying, what is the purpose of chain surveying, and different measurements it can take, and entire discussion about chain surveying. The principle of chain surveying is chain triangulation. Chain triangulation means dividing the given area into number of interconnected triangles and rectangles. In chain surveying, we take linear measurements, meaning we'll take lengths, areas, volumes, etc. We cannot directly measure areas. We will take lengths and then use some formula to get the areas. And then plotting is done with the help of measurements already taken with chain survey. The error in plotting a triangle is minimum when no angle of a triangle is less than 30 degree and more than 120 degree. Such triangles are said to be well-conditioned triangles. Any triangle in which the angles are in between 30 to 120, they are said to be well-conditioned. For more accuracy, we need to arrange the triangles such that they are well-conditioned. We will see the suitability of chain surveying, where it shows. Means, if the ground is fairly level, then we can use chain surveying. Whereas in hilly areas or undulated area, chain may not give a proper result or accurate result because of undulations. So it is suitable if the ground is fairly level. And the ground is open with simple details. It should not be like a forest. The land should be filled with simple details. And the purpose of survey is to draw a plan for a large scale. Then we can go to chain surveying. Moreover, the area should be small in extent. Otherwise, we will use other methods of surveying. If the area is small, we can go for chain surveying. In these four cases, chain survey gives a good result. Chain survey, it is not suitable for larger areas and areas with crowded with many details, and it is difficult for or wooded country. These are the different equipment being used in chain survey. We will use chain, tape, ranging rods. You know the use of tape. Tape may be used to take the offset length and measuring the chain edge. You have ranging rod, which is used for ranging of a line. Cross staff, we have cross staff, which gives us perpendicularity of the offset. We will use arrows so that at every chain length we can fix one arrow. We will use pegs for permanent points like starting point and ending point. Plumb bob is used to check the verticality of the chain. Most of the cases we will avoid using plumb bob. In undulated areas there may be a case where we have to use plumb bob. So in this diagram we have two different chains. This is 30 centimeter length, this is 20 centimeter length. And we have different types of ranging rods. Here we can see the colored ranging rods. The chain will be something like this. This is brass handle which helps us to tightly pull the chain up lay the chain. This is ring which is in between every chain link. There are some of the tallies at every 1 meter length. This is arrow. Arrow is having internal diameter of 50 mm. The thickness of the arrow is 4 mm. Here we have a ranging rod of different colors. The height of each color is 20 centimeter. The ranging rod height may be 2 meter or 3 meter. The tip of the ranging rod is having 15 centimeter length. We have offset rod, which is very similar to our scale rule. The function of chain is to measure the length. It consists of galvanized mild steel wire of 4 mm diameter. Chain have links. Each link will have 3 rings. It consists of brass handle at either end. This is the diagram which shows the metric chain. The length of the chain is the distance between outside of the handle. The length of link is the distance between the center of middle ring. So we have 3 rings in which we have to consider the middle ring and center of the middle ring for measuring. Brass tacks or tally is fixed at regular intervals. Generally at 1 meter interval we will have tallies. At every 5 meter interval we will have tags. We have different types of chains: metric chain, engineer's chain, Gunter's chain, revenue chain, steel band or band chain. These chains are used for various purposes in various departments. We'll discuss in detail. Metric chain is available in different lengths like 20 meter or 30 meter. This chain consists of this chain consists of 100 links. Means if the chain is 20 meter, it will have 100 links. If the chain is 30 meter, it will have 150 links, which means that each link length is 20 centimeter. Tags are fixed at 5 meter interval. Small brass rings are provided at every meter length until the end of the chain. Then we will have engineer's chain. The length of engineer's chain is 100 feet. Each link is provided with 1 feet, means we will have 100 links. It is used for engineering surveys. The distance measured are recorded in feet and decimals. And we will have Gunter's chain. This is used for measuring lands in acres for agriculture purpose. It is of 66 feet length, provided with 100 links, which means each link length is 0.66 feet. The specialty of Gunter's chain is if we lay 10 Gunter chains, the area of 10 Gunter's chain horizontally, if we lay vertically and horizontally, the area covered under the 10 square Gunter's chain is 1 acre. This is the specialty of Gunter's chain, which is used for measuring especially agricultural lands. The revenue chain is 33 feet long and provided with 16 links. Therefore, the length of each link is 2 1 by 16 feet. It is mostly used in cadastral surveys where we have to locate the boundaries. This is the detailing of metric chain. We have steel band or band chain. It is steel ribbon of width 12 to 16 mm. The length may be 20 or 30 meters. It is divided by brass studs at every 0.2 meter. and numbered at every 1 meter length. It is used in high degree precision works and it is usually broken and difficult to repair. Where we need more accuracy, we can use steel band or band chains. This is steel tape, which you will come across many times. This is also steel tape. It is different from the previous one. As we have already discussed, the different equipment used in chain survey are chain, tape, arrow, ranging rods, offset rods, pegs, and number. Tapes are used for measurement of lengths, generally for measuring Chineses and offset lengths. Commonly used tapes are metallic tape and steel tape. Coming to metallic tape, it is a cloth tape reinforced with brass, copper, and bronze wires. Available in different lengths like 10 meter, 15, 20, and 30 meter. The markings on the tape are decimeter and meter. The tape is provided in leather case fitted with a winding device. This shows a typical top view of metallic tape. And we have steel tape. It is made of steel or stainless steel of width 6 to 10 mm. The tape is available in 10, 20, 30 meter lengths. This is provided in a leather case or rust-proof metal case. The steel tapes are light and delicate. It is used for measuring with high degree accuracy. So this shows the typical top view of steel tape. We have other types of tapes also, like linen tape, invar tape, fiberglass tape, and digital memory tape. Linen tape is made up of cloth of 12 to 15 mm width and vary in length like 10 to 30 meters. It is affected by moisture and it shrinks. It is not used for accurate measurements of a distance. We have invar tape, which is used for high degree of precision works or high degree of precision measurements of baseline and geodetic survey. It is an alloy of steel and nickel. The tape is 6 mm width and available in 20, 30 and 50 meter lengths. The tape is delicate and costly and it is to be handled with proper care. In so many competitive exams, we may come across objective questions like what is the tape which gives high degree of precision in the linear measurement. In such cases, we have to give answer as invar tape. Fiberglass tape. These are manufactured with fiberglass with a PVC coating. Its length is practically unaltered. It is suitable for locating interior details or short distances. Finally, we have digital memory tape. It is revolutionary new digital and portable computerized tape with multifunction arrangements. It measures, memorizes, and calculates the measurements. Displays the results in the digital form. It is very easy to operate. As it is digital, we no need to remember. All the results are saved or we can access at any time and no need to take the measurements as it displays on the display module. And we have ranging rods which are very essential in chain surveying. These are available in 2 meter or 3 meter lengths. This will have a diameter of 2.5 centimeter. It is made of wood seasoned timber or hollow pipes, painted alternatively black and red or white and red. A colored flag is provided at the top to see long distances. At bottom, iron shoe is provided to insert in the ground. We have different uses of ranging rod. They may be used for establishing intermediate points on the survey line, or it may be used for marking the position of survey station clearly. This diagram shows typical ranging rod of 2 meter length. Here we can see that every color is having 200 mm length. The diameter is 2.5 centimeter. That this shoe length will be 100 mm. Arrows. These are also called as marking or chaining pins. These are used for mark the end of each chain length. The arrows are made of 400 mm in length, pointed at one end for inserting into the ground. The top is bent into a ring for facility to carry. The top should have a piece of red or white tape tied for easy visibility. This is the top view of arrow. Here we can see the internal diameter is 550 mm. Thickness will be around 4 mm. Total length is 400 mm. Pegs are used to mark the position of stations. We have two types of pegs, wooden pegs and iron pegs. Wooden pegs made of seasoned timber of 15 cm long. These are 25 to 30 mm square cross sections. They are firmly driven into the ground. Project about 4 cm above the ground. Project about 4 cm above the ground. Iron pegs of 15 cm long and 1 cm dia used in place of wooden pegs. A nail is also generally driven on the top of the peg to indicate the exact location. This shows diagram of wooden peg where the total height is 150 mm. At the top we can see a cross section of 25 by 25 mm or 30 by 30 mm. We have offset rods which are similar to ranging rod having slight long lengths. It is graduated in meters and 1/10 of meter. A hook is provided at the top of offset rod. Nowadays, it is not being used because of its heavy weight and huge length. We have plumb bob. It is made of brass or conical shape and suspended from a thread attached at the top. It is for measuring sloping distances. It is also used for centering the compass, plate table, or theodolite over the given ground stations. At the place where we have to measure sloping distance, we will use this plumb bob for checking the verticality of the chain. This shows a diagram of plumb bob. We might have come across this so many times. Every mason is having this plumb bob along with him. In plastering works also they will use this plumb bob for checking the verticality and smoothness of the wall. Now we'll discuss some of the definition in chain survey. First we'll have survey station. A survey station is a point of importance at the beginning and end of a chain line. It means starting and ending point may be called as survey stations. It is a point on the ground where we do the survey. There are mainly two types, main stations and subsidiary stations. Main stations are the end of the survey lines. They should command the boundaries of the survey. Subsidiary stations are the points selected on the main lines. They are necessary to run auxiliary lines to locate interior details. Here we can see some layout of a layout showing baseline, tie line, and check lines. Baselines means the line connecting the main stations is called baseline. Baseline is the longest line in the entire survey. It is an important survey line. Baseline builds up the framework of a survey. It should be laid on a level ground and through the center of area as far as possible. Here we can observe the baseline. The precision of the whole survey depends on straightness and accuracy of baseline, because through which we will create number of triangles and we will measure the areas. The baseline length should be measured twice or thrice so that we will have more accurate results. It should be correctly measured horizontally. Select the baseline in the center of an area. This avoids accumulation of errors in the system of triangles formed. This is the object of such a selection. Subsidiary line or tie line. The line joining the tie stations are called subsidiary lines or tie lines. These lines are used to locate the interior details which are too long from the main survey line. These lines can also serve as check lines. Check line means each triangle must have a check line so that we can check the accuracy of the work. It is a line measured on the ground. The length is computed from the plan or after plotting. The computed length should tally with the length on the ground. It is generally taken from the apex of the triangle. So essentially these lines are used to check the accuracy of the work which is done in the field. Selection of survey stations. The following points are to be kept in a view while selecting the survey stations in a chain survey. Main stations should be mutually visible. The main principle, that is working from whole to part, is to be followed. If possible, a long line should be run through the center of area. The baseline should be laid off as far as possible on level ground. All triangles should be well conditioned. We have already discussed the meaning of well conditioned triangle, which is having all the angles in between 30 degrees and 120 degrees. Each triangle should be provided with one check line. The survey line should be as few as possible. The survey line should run on the level ground as far as possible. Required number of tie lines should be run to locate details and to avoid long offsets. The tie line chosen should be such that the length of offset within the tape length or chain length. The survey line should run avoiding the obstacles to ranging and chaining, because if the survey line comes along or come across an obstacle, it may cause difficulty for measuring the linear length. The larger sides of triangles should run close and parallel to the boundaries, buildings, and important features. So those are the points which we have to remember while doing the chain survey. Coming to ranging, the length of survey line should be taken straight. For this, we have to establish intermediate points on a chain line. If the length of the survey line is less than length of chain, the length can be measured directly. If the length of the survey line is longer than the chain, then we have to adjust, then we have to make the chain straight with the previous chain. If the end station is not clearly visible, then intermediate points have to be established. So the definition is something like this. The process of establishing intermediate points on a chain line is called ranging. So here we are going to establish different intermediate points on a chain line which serves the chain line to be straight. The ranging is necessary for getting straight line and correct line. We have different methods of ranging: direct ranging and indirect ranging. Direct ranging is possible if the two terminal points of the survey line are mutually indivisible. Means from one station, other station should be visible. At the same time, from other station, the initial station should be visible. In such cases, we can go for direct ranging, which says if two points of a survey line are mutually intervisible, then we'll go for direct ranging. We have indirect ranging also. When two intermediate points are interpolated by taking indirect measurements, such ranging is called indirect ranging. It is done in the case of raised ground or a hill. Direct ranging can be done by eye ranging or line ranger. Eye ranging means the ranging by eye is done using the following steps. The ranging rods are to be fixed at each end of the line to be measured. Ranging is to be done by standing 1.5 meter beyond the first rod. The assistant is to be directed to hold the ranging rod vertically at arm's length, where the intermediate station points is to be established. The assistant is to be directed to move left or right code signals until the three ranging rods are clearly in a straight line. Fix the ranging rods, and when the intermediate ranging rods are in a straight line, which means the line is straight, the code of signals are used during the ranging process. We have different code of signals. Rapid sweep with right hand indicates move rapidly to the right. Rapid sweep with left hand indicates move rapidly to the left. Slow sweep with right hand indicates move slowly to the right. Slow sweep with the left hand indicates move slowly to the left. Right arm extension means continue to move right. Left arm extension means continue to move left. Right arm up, move to the right means plumb the rod the right position. Left arm up and move to the left means plumb the rod to the left. Both the hands above head and then brought down means the point is correct. Both the arms extended forwarded horizontally and the hands depressed briskly means fix the ranging rod at that point. So these are the different signals being used in a chain survey. These signals must be remembered while doing the chain survey because the surveyors may be standing at longer distances. We cannot talk to them directly because the distance is very long. So in such cases, these signals will help us for taking accurate steps in the survey. Thank you for today's class. So far we have learned what is chain surveying, what are the principles in chain surveying. We have learned the different definitions in chain surveying as well as different instruments used in chain surveying. So in this class, these are the objectives we have learned. In next class, we will be learning other methods of ranging. Along with we are going to solve some of the numericals in chain surveying. We have to cover an indirect ranging as well as we need to solve some numericals in chain surveying. So thanks for listening to me and thanks for today's class. We will close the session for today and we will continue in the next class.